This is a review of question 2 in exam 3. In this question, two objects are connected by a light string that passes over a pulley, as shown in the figure to the right. The incline and the pulley are frictionless, and mass 1 is equal to 5.00 kilograms. And mass 2 is equal to 8.00 kilograms. And the angle of the incline, theta, is equal to 25 degrees. The system will accelerate. Note the statement that the incline and the pulley are frictionless. So we don't have to worry about a friction force in this problem. In part A, we're asked to draw the free body diagram for each object, breaking up the forces so they are either in the direction of the motion or perpendicular to the direction of the motion. And I'm a little surprised how much trouble this question gives you, because we've done it many times. But let's do it again. So we know that mass 1 has its weight acting down, so it has perpendicular to the y direction, if we call this the x direction, and we call this the y direction. The x direction would be the direction of the motion, and the y direction will be perpendicular to that direction. And the component of the weight along the y direction is mg cosine theta. This is theta. And the component of the weight acting in the direction of motion is in the minus direction. That's mg sine theta. And the tension is acting up the incline. So if we were to draw a free body diagram for mass 1, you could draw it like this. The tension force in the direction of the motion, mg sine theta acting opposite to that direction, the normal force in the plus y direction, and mg cosine theta acting opposite to it. That takes care of mass 1. For mass 2, it's simpler. We just have the tension force acting up and its weight acting down. And that's the answer to part A. In part B, we're asked to find the acceleration of each object. Well, the two objects are connected by a common light string, and so the string and the two masses are all going to move with the same velocity and the same acceleration. If we look at the free body diagram for mass 1 and sum the forces in the direction of the motion, we get that the tension force minus m1 g sine theta. Are the sum of the forces in the x direction. So that's equal to m times a, mass 1 times the acceleration. The acceleration for mass 1 is in the plus x direction, and then mass 2 is going to be in the minus y direction. So I can call the direction down the positive direction if I want, and just say that y is positive in this direction. If I do that, then I sum the forces in the y direction, and that's equal to m2g minus the tension is equal to m2a. All right, then I can call this equation 1, and then I can call this equation 2. I see if I add equation 1 to equation 2, the tension forces cancel out, and I simply have m2g minus m1g sine theta is equal to m1 plus m2 times a. And then I can solve for a. A is equal to m2 minus m1 sine theta times g, factored out the g, divided by m1 plus m2. So if I carefully put in the numbers, I've got mass 2, which is 8, minus mass 1 times the sine of 25 degrees times g, 9.8 meters per second squared. Notice I left the kilograms out because I'm going to have kilograms in the denominator, and so they're just going to cancel out. And I have 5 plus 8 in the denominator. And when I calculate that, I get 4.43 meters per second squared. Now, if I had assumed that the acceleration was in the opposite direction, that is, if that m1g sine theta would dominate m2g, then the acceleration would turn out to be negative, and that would tell me that I had chosen the wrong direction. In part C of the problem, we're asked to determine the tension in the string. Well, I have two equations to choose from. I can use equation 1, or I can use equation 2. Equation 2 looks simpler, so I'll rewrite equation 2 as the tension is equal to m2g minus m2a, which is equal to g minus a times m2, which is 9.8 minus 4.4 meters per second squared times mass 2, which is 8 kilograms. And when I solve for that, I get the tension is equal to 43.0 newtons. And that concludes this review of problem 2 in exam 3.